2.1, part 2. Here we go.
Reminder, a geometric sequence has successive terms that have a common ratio r. This means that each term is multiplied by the same number to generate the next term. The general form of a geometric sequence is usually the best form to use. G of n equals g of k r over n minus k.
Love it. All right, so example 1, we're going to find the geometric sequence with g sub 3 equals negative 3 and r equals 10. So here we go. So what's my g sub n? Where do we start? With negative 3, and then times what? 10 to the power of n minus 3. Why is it 3 this time? Because it's my third. Okay, it's g sub 3. Go ahead.
Example 2.
Yeah.
Let g of n be a geometric sequence with g of 2 equals 24 and r equals 1/2. Find an expression for g of n. Use the expression for g of n to find g of 5.
All right, do we have everything ready to set up g of n?
Yes.
Yeah. All right, so let's set it up. So g of n is equal to 24, and then times 1/2 to the power of n minus 2. All right, because we're using g sub 2 on that one. All right, and so from there, we can find g sub 5. And we can do this one without a calculator. We're smart. All right, so now we have 24. How did I get 5? 24 times 1/2 to the power of 5 minus 2. And so 5 minus 2 is 3. So 1/2 to the power of 3. 2 to the power of 3. 1/8. All right, so we got 1/8 times 24, which is? 24 times 1/8 is 3. All right, all right. All right, keep going, Ethan. You're doing great.
All right. You want me to read the examples above?
Yeah, keep going.
The examples above were relatively quick and easy, but we were given one term of the sequence and the value of r. However, we can deal with problems that give us 2 terms but not the value of r. Geometric sequences given 2 terms. Use both terms to create one equation in general form. Use the larger k value term as the g of n term. Step number 2. Solve for r using the equations created from step 1. Step number 3. Use the value of r found in step 2 along with either term given in the problem to write the general form of the geometric sequence.
Beautiful. Great job. All right. So in example 3, we're going to have g sub 3 equals negative 2 and g sub 6 is equal to 128. And eventually we're going to find g sub 11. All right. So this is very similar to our arithmetic. However, it's not as quick. All right. And so a ratio is actually being multiplied each time. All right. And so the way we're going to do it is we're going to find which one's second, g sub 3 or g sub 6? G sub 6. And so I'm going to go from 128, and that equals where I started from, and I'm going to use my ratio. How many times? I go from 3 to 6. So how many times did I use this ratio? 3 times. And so this is my ratio to the power of 3, because they're being multiplied, not just added this time. All right? And so now I need to solve for r. So what's my first step in solving for r? Divide by negative 2. So now I have negative 64 is equal to r cubed. All right. And so now I need to solve for r. So how do I solve for r? Not a square root, but a cube root. All right. And so a cube root is really like a power of a 1/3. And I want to do it that way in case like you look for it on your calculator. There is a cube root on your calculator. However, like if we were to do a power of 5, that would be a what root? A 5th root. And so that's a power of 1/5 then. All right. So put in your calculator, negative 64 to the power of 1/3. So r is equal to negative 4. All right. And so from there, now we can find an expression for g of n. So now we have g of n is equal to, does it matter which term we use? No. Okay, so I'm going to use this one that's closest to 11. However, could you use this g of 3? Yes. All right. So I'm going to say 128, and then times, what's my ratio? negative 4. And then I'm going to go to the power of n minus what? 6, because I'm using g sub 6. All right. And from there, now I'm going to find g of 11, g sub 11. And so from there, I'm just going to substitute in 11. And dear goodness, we need a calculator for this one. All right, so what do we got? Negative 131,072. All right. All right, so we got one more example on our notes today. So we have g of 2 is equal to 48, and g of 7 is equal to 1.5. So which one comes second? The 1.5. And so when we set this up, we're going to have 1.5 is equal to, where did we start? 48. And how many times did we use our ratio? 5 times. All right, and so that's why we have r to the power of 5. And so now, what do we need to do? Divide by 48. And so this one's going to get a little nasty, but it plays nice. And so now I have 1.5 over 48. But what do we want to do with that? So that's going to equal r to the 5th, right? And so now what do we want to do? I need to solve for r. So how do I solve for r? I do what, Kyler?
You go to the other side and you like to get the fifth root.
Fifth root it. I fifth root it, exactly. So r is equal to this 1.5 over 48 to the 5th root, so it's to the power of 1/5. So now we're going to put that into our handy dandy calculator. 0.5. So we got a r of 0.5. All right. So from there we can build our g of n. And so g of n is equal to, does it matter which one I use? No. Which one do you want to use? 7. Awesome. And so now we're going to say 1.5 and then times 0.5 to the power of what? N minus 7, because I started out using my 7th. All right. And so now, once I build my g sub n, now let's find g sub 11. So we're just going to substitute in 11. And we might have to math frac it because it's going to give me a nasty decimal. And once I math frac it, we end up getting, we end up with 3 over 32. All right. All right. So you have the worksheet A and 5 for 5.